I'm Anil Kumar. In this video, we'll discuss cost function in details. I have three examples. With the help of these examples, we'll actually understand the relation between cost function, marginal cost, and average cost. You can always pause the video, copy these questions, and then look into my suggestions. Now, in the first question, we are talking about the cost function, and we need to find production level that minimizes average cost per unit. In second question, we are given the average cost, and we are trying to figure out the marginal cost and its significance. In question number 3 is kind of a review. You are given the cost function. You need to find cost, average cost, marginal cost, and also work with minimum average cost, right? So I'd like you to pause the video, copy these questions, and then look into my solution about question 1, 2, and 3. Let's first begin with defining our functions and understanding the relation between them. Let us first understand all the cost functions. Cost function capital C of X is the cost of producing X units. Then we have marginal cost, which will designate by derivative of cost function is the rate of change of cost, right? So it makes sense. Capital C's are being used for cost and marginal cost functions. Average cost, C of X, lowercase, is cost per unit when X units are produced, right? And this is a condition that for minimum average cost, marginal cost is equal to average cost. We'll actually derive and prove this in a minute. Now let's actually look into a kind of a graph which represents all these cost functions. And then we will take up questions based on cost. So let us say items are being produced, X number of items are being produced, and that is how the cost varies. So this we are writing capital C cost function. Now I'm not using any units here. So here in North America, we can use dollars. In your country, use the unit of your country for cost. Okay, so this graph provides you the cost for producing X items. So on this, let's say we have X units of items. That is the cost. Most of the time in North America, we use dollars. So let me put dollars here. Now it really means that at any particular point, let's say at this point here, then the average cost will be kind of at this point, the cost is capital CX, and here we have produced, let us say, X1 items. And at this point, let us say the cost is capital C X1. Is it okay? In that case, average cost, which is C, lowercase c, right? Lowercase c, for producing X1 items will be cost for producing X1 items, capital C, over X1. The number of items being produced at this level, right? So that is the average cost. The marginal cost will be, we're using capital C derivative of the cost, right? So that is going to be the marginal cost. Marginal cost gives you rate of change of cost, correct? So on a graph, marginal cost will be shown by the derivative, correct? So if I draw a slope at a point, it will give me marginal cost, correct? So if I draw a slope here, kind of like this slope is going to give me the marginal cost. Perfect. That is what marginal cost is. Now you can see here, for the cost function, initially the slope is pretty high. That means the rate of change of producing the next item is very high initially, right? But as the production level increases, it kind of lowers down, right? Marginal cost is basically the rate of change of cost at any particular point on the cost function, right? So what you see here is that there is a point after which the marginal cost starts increasing. So first it is very high, then it kind of decreases. I mean, not increasing at a higher rate, but increasing at a lower and lower rate. And then we reach a point of inflection. So this point here is referred to as point of inflection. So here the concavity changes. So at this point, concavity changes. So from derivative, second derivative will be 0 at this point, right? Concavity changes. So at that particular point, we have minimum marginal cost. So you will realize that at point of inflection, we have minimum marginal cost. Now, let us try to understand the relation between average cost, cost of production, and marginal cost, right? So average cost, as we define, is total cost divided by the items being produced, right? That becomes the average cost. Now, if I have to find minimum average cost, what will I do? For minimum cost, I need to find the first derivative and equate it to 0, right? So for minimum cost, average cost derivative should be equal to 0. So applying the quotient rule, we get x squared, derivative of cost times x minus derivative of x is 1 minus c of x, the cost function. Now for this to be 0, numerator should be 0, correct? That is to say, x times marginal cost minus cost is equal to 0, or we can say these two are equal. That means x times marginal cost is equals to the total cost. And if I divide by x on both the sides, I get marginal cost is equals to average cost. You see that? Cx over x. So what we realize here is that for minimum cost, the condition is that marginal cost is equal to average cost. And it makes sense, right? Since if the marginal cost is lower, you should produce higher, right? You should produce more. And if the marginal cost is higher, produce lesser. So the equilibrium comes at this stage when you minimize the cost. So I hope that concept is clear to you, right? Now at times you may be required to sketch from this graph of cost the marginal cost graph. So as you can see, the rate of change is kind of higher initially, but then it becomes minimum at point of inflection. So that curve could be like this, kind of like this. Is it okay? Where it is minimum referring to the point of inflection. So that becomes the rate of change cost or the marginal cost graph for you, right? This minimum cost is basically referring to overheads. So if you have this minimum, then it means cost of producing extra item is almost 0, but this refers to overheads. So when we are talking about the business and economics, then these terms become very critical to understand, right? So I hope all these terms are very clear to you. So let me again define. Cost function is the cost of producing X units at any time of production level. Marginal cost is rate of change in cost. So it is derivative. Marginal cost is the derivative of d dx, rate of change of the cost function, correct? Average cost, small lowercase c of x, is cost per unit when x units are produced, per unit cost. And the minimum average cost, for minimum average cost is equal to marginal cost, which we have just derived here. Now based on this, let us take our 3 questions and understand further. A company estimates that the cost of producing X units of a product is C equals to 800 plus 0.04x plus 0.002x square. Find the production level that minimizes the average cost per unit. So we'll take cost in dollars for all our examples. Okay. Now we are given the cost, which is 800 plus 0.04x plus 0.002x square. Now whenever we are given cost, it is assumed that x is greater than 0. Okay. Find production level to minimize average cost. Now what is average cost? Average cost is C of x, which is total cost over number of items being produced. So it's that ratio, right? So we can find average cost from the given cost as 800 plus 0.04x plus 0.002x square divided by x. That becomes the average cost. So we can rewrite here the average cost. I'm using lowercase c for this. We get 800 over x plus 0.04 plus 0.002x. Now since we want to find minimum average cost, then we'll find its derivative, right? So we'll find the derivative of average cost, which is minus 800 over x squared. This is 0, and here we get plus 0.002. And for minimum critical number, this has to be equal to 0, right? So we're trying to find the critical number now. Okay, now if you equate it, you get 800 over x squared equals to 0.002, or you can say x squared is 800 divided by 0.002. So let's figure this out. It is 800 divided by 0.002. That gives you 400,000. So x is square root of 400,000. So which is square root of our answer, which is equal to 632.455, correct? So that becomes the answer for x. Now, for a production level of 632 items, we are going to get minimum average cost. Now, how do we prove that this is minimum? There are two ways to do it. One is we can analyze the first derivative itself, which is here. And the second way is we can find the second derivative. So let me find the second derivative. So second derivative for average cost will be, so this will be minus and minus becomes plus. 2 times 8 is 16. So it is 1600 over x cubed. Now this number is greater than 0. And since second derivative is greater than 0, we are expecting concave up type of a graph, right? So that means we have a minimum, correct? So that is how we can show that it is minimum. And therefore, our answer is find the production level that minimizes the average cost. Production level is so many items or units. So x is equal to 632 units. Correct? So that is how it is. And if you sketch the graph of this function, as I'm showing here, it will be kind of like this. Is it okay? So that is how it could be solved. Now let's move on and take the next question. Here is question number 2. The average cost of producing x units of a commodity is C of x equals to 21.4 minus 0.002x. Find the marginal cost at a production level of 1000 units. Explain the significance of your answer. So what we are given here is the average cost. So let's write average cost which is lowercase c of x, is equal to 21.4 minus 0.002x. Now, as you know, average cost basically is the ratio of cost with items being produced. So I've written here capital C over x. So that is equal to 21.4 minus 0.002x. So from here, we can actually find the cost function. So we have the cost function as what? So the cost function capital Cx is equal to x times this. So I'm writing this as 21.4x minus 0.002x squared, right? That becomes the cost function. Now we need to find marginal cost at a production level of 1000. Now what is marginal cost? Marginal cost is derivative, right? So now we will find marginal cost, which is derivative of this cost function. So the derivative is 21.4 minus 2 times this, 0.004x. Now if you have to find marginal cost of producing 1000 units, then in that case we'll just substitute x by 1000, right, and calculate the answer. Minus 0.004 times 1000, correct? So that is 21.4 minus, when you do 1000, it's 4 cents. So 1, 2, 3, 4, right? So that is 4. And that gives you the 0.4, right? Now units we are considering by default, we are considering dollars as our units, but you can choose the units of your country. That's why I've not written units in any of my questions here. Now part B of this question is explain the significance of your answer. So when we say that the marginal cost at this level of 1000 is 17.4, it means what? So it really means that cost of producing, this is very important to understand, cost of producing 1000 first item unit is dollars 17.4. So if I'm using units dollar, it'll be, that is the amount, that is the cost for producing the next item, right? So that is what average cost is. It is rate of change of cost. So I hope this is absolutely clear to you. Let's move on and take the last question. Now here is the last question of this video. For the cost function capital C of x, 40,000 plus 300x plus x squared, find cost, average cost, marginal cost at a production level of 1000 units. Part B is the production level that will minimize average cost, and then we have to calculate the minimum average cost. Correct? So we are given the cost function capital C of x as equals to 40,000 times 300, plus 300, plus 300 x plus x squared. If you have to find cost for 1000 units, we can just say C of 1000 is equal to what? Correct? Replace x with 1000, calculate your answer. So you get 40,000 plus 300 times 1000 plus 1000 square, right? That becomes the answer for producing 1000 units, and it is 40,000 plus 300 times 1000 plus 1000 square, which is equal to, so it is 134,40, right? So it is 1,340,000 units. Use dollars if you're in North America, or any currency you want to use. So that becomes the cost for producing 1000 units. Now what is the average cost? So average cost will be, we have to divide by total number of items, right, to get the average cost. So for average cost, we'll do capital C of x over x. So in that case, we could divide this amount by 1000. So we have 134, 4 zeros, 1, 2, 3, 4 divided by 1000. So that gives us 1, 2, 3. So the average cost is 1340. Units, will use dollars in our case. Correct. Now the last question, third part is, what is the marginal cost at this production level? Now marginal cost you get by finding the derivative. It is rate of change, right? So marginal cost is rate of change of the cost. So that will be 300 plus 2x. So if I substitute here 1000, what do I get? So I get marginal cost for 1000 is 300. 300 plus 2 times 1000, which is 2000. So it is $2,300. So that really means cost of producing 1000 first item. Is it okay? So that is what the marginal cost is. Now part B here is the production level that will minimize average cost. Now to minimize average cost, what we have to do is we have to equate average cost and marginal cost to get our answer, right? So we could do that, or it is the level at which marginal cost is same as the average cost, right? Either way you could do it. So what we will do now to find that answer, we'll use the right side of the page. So for minimizing average cost, the condition is, let me write down here, minimum average cost is at a level when average cost is equal to marginal cost. Is that okay? Now average cost is all this divided by x. So we'll write this average cost here as 40,000 divided by x plus 300 plus x equals to marginal cost. We got this expression as 300 plus 2x, correct? So we have to equate this and then find the value of x. So from here 300 cancel. We have 40,000 over x is equal to x goes to that side. So we get 2x minus x, which is x, or we get 40,000 equals to x square. So x is equal to square root of 40,000, right? So x is equals to square root of 40,000. Right, so let's do this, which is square root of 40,000, 200. So which is $200. So 200, this is not in dollars. X is the number of items being produced, right? So in this particular case, X is the number of items being produced. So when you produce 200 items at that time, the average cost is equal to marginal cost, and that is the minimum average cost for production, correct? So that is your answer B. Now part C is minimum average cost. So to find minimum average cost, I'll substitute 200 in the cost function. Is it okay? In the average cost function. So let's do that. What we have now here is part C, which is at 200 minimum average cost. We are given the cost, we'll divide by the total cost by 200, right? So it is C, the cost at 200 divided by 200, right? So that becomes your average cost at 200. So which is 40,000 plus 300 times 200 plus, I should have written there anyway, 200 square divided by 200. So let's find this cost. So it is 40,000, 40, 1, 2, 3, plus 300 times 200, plus 200 square equals to divided by 200, 700. So 700 becomes the minimum cost it becomes the minimum average cost at a production level of 200, right? So I hope this is very clear to you. So here in this question, we actually found the cost for producing 1,000 items, which is that much. And then we found average cost of producing these many items by dividing it by 1,000, right? Straight away. Marginal cost is derivative of the cost function. Derivative is 300 plus 2x. Substituting 1,000, we got $2,300 as the marginal cost. To find the minimum average cost, we equated average cost with marginal cost, solved the equation, found that the production level should be 200 units. Now at that much of units, the cost function will be, the average cost function is actually the capital cost divided by x for x equals to 200. So we calculated this as $700, right? So in our case, we got this cost as $700 for part C, minimum cost. So I hope with this, the connection between the cost, average cost, and marginal cost is fairly clear. We'll take up more videos on demand functions and elasticity in the coming videos, and I hope that helps. Feel free to write your suggestions and your views, and if you like and subscribe, that'll be great. Thank you and all the best.